All right, so we're starting with a couple of heparin-based questions. We're going to look at question number one, and question number one is asking us for the flow rate that we would set the IV pump at mLs per hour. I always start with what the question is asking me, not with all the orders and everything. So if you see what I have highlighted there on the screen, all right, that's where I start because that tells me what I need to do to set the problem up. All right, so I already know if it's mLs per hour, what I need is my total volume of mLs and my time in hours. So this is really going to be a desired over have question. Okay, everybody with me on that? If
Yes.
now
Yes.
speak up. If you don't understand why I'm saying that, speak up now. Okay. So, in order to solve this problem, I'm sorry. We good? Okay. In order to solve this problem, we need a couple of things. So, the first thing we're going to need is the patient's weight. And the reason why we need that is because our order is weight based. All right. So, we're going to take our weight and just write it down for now because I'm going to flip out of the screen. All right. So, our weight is 172 pounds. And then our order is 18 units per kilogram per hour. And that's good because we have to go to mLs per hour. So we already know that our dose is ordered in hours. So that's a good thing. All right. And then what you have on hand. So what do you have on hand? You have 25,000 units per 500 ml.
Right.
Okay. The other units is your loading dose. Why does it say that? It's trying to confuse me, Miss Sue. No. When you're giving heparin, usually you're going to give like a loading dose first, and then you'll start to add more heparin in, and you'll titrate it until you get to what? What do you want to titrate this to? What do we use to measure heparin in the body?
The weight?
No. So for Coumadin, we use PT and INR, right?
Oh, yes. I'm sorry. Yes. PTI and
Heparin, what do we use?
INR?
No. PTT or APTT?
APTT. Okay. Right.
What is the antidote for heparin?
Vitamin K? No. Heparin,
protamine sulfate.
Yeah.
Okay. And what else do you have to monitor besides the APTT when you're giving heparin? And why? Anybody? Platelets. Why?
To make sure it's not aggregated or something like that. I'm not sure.
Okay.
Mindful and bleeding.
A condition called heparin-induced thrombocytopenia, or HIT, we call it HIT. Heparin-induced thrombocytopenia, which means I gave you heparin last night and your platelets were 300,000 and this morning they're 75,000. This patient likely has a problem with the heparin and they can't be given the heparin, and a lot of times not even in a hep lock. So you have to be aware of that, right? So when you're giving this, you're going to be monitoring the APTT because your job is to get that APTT to what? How many times the value? What, first of all, what is a normal APTT? Anybody? If you weren't on drugs, it's in your runner's book. Let me just open up your runners so I can give you the value from them.
Yeah.
Because this is what you would use. And I want you to know all this because this is important for you to know all this and why you're doing this. Hopefully it helps you understand why you have to do the calculations and everything that you have to do. While I'm waiting on this to look up, we're just going to keep working. All right. So we've taken those things. Everybody has their weight now. Everybody has the dose that is ordered, and everybody has their desired dose on hand, correct?
Correct.
All right, so we're going to go to the white screen. All right, so the first thing we're going to do is we're going to take our weight, which is 172 pounds, and we're going to do what to convert it to kilograms?
Multiplied by 2.2.
Multiply it.
Divide by 2.2.
Divide it.
I'm sorry, divided by 2.2. I'm sorry.
Okay. Want to keep talking to yourself about that because these are common mistakes that nurses make. Sometimes I make a mistake, I go the wrong way, but you want to make sure that you're constantly talking to yourself so you don't make those mistakes because those mistakes will get the calculation wrong. All right, so divided by 2.2, and what do we get?
78.
78 exactly?
Well, 0.1.
No, nurse, don't give me a number that's not exact. Okay, so how many people got 78 exactly?
I got
So
70.
important that you understand this, okay? This is a critical care dose. So you can't just say, okay, well, it's about. No, we have to be on point.
78.
We got 78.18 infinity is what we got. And you need to leave that whole number in your calculator, okay? That's why I'm stressing that because this is so important. All right, now if you look in your book on page 673, which I want you to take a look at that because you're going to want to know that. It talks to you about what your normal APTT is and what it should be if we were adjusting a dose. All right, so normal is going to be 21 to 35. Okay, and then when you're adjusting the dose, so you're going to titrate this heparin until it's 1.5 to 2.5 times the dose. And you need to know that because on the test question, they're going to say your patient's APTT is 80 and you have an order to administer heparin. What are you going to do? And you need to know whether you're going to administer the dose, withhold it, or call the doctor to increase it. Okay? All right. So we got this 78.18 infinity, and everybody left that in their calculator, right?
Yes.
All right. Now our order dose is 18 units per kilogram per hour. So we're going to multiply our long number that you left in your calculator times 18. And you should have got 1407.27. And I just represent this again as infinity. Okay, you leave that whole number in the calculator. Do not erase anything. And this is units now per hour. And we're looking for mLs per hour, okay? Now we can just take this over, and this is why I said it's desired over half, because now we have our desired dose. That's what the doctor ordered. For this patient, the doctor ordered 1,407.27 units per hour. On hand, you have 25,000 units, and your vehicle is your 500 mLs, right? Your units cross out here, and you'll be left up with mLs per hour. So now all you have to do is take that number and divide it by the 25,000. And then you got to multiply whatever you got, which was 0.056 blah 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 times the 500, right? And that should have gave you 28.145. Okay, now let's look at this number. Normally, if I'm setting an IV pump and it's in critical care, I'll probably round it to the nearest 10. So this 4 would determine that. And so my answer is likely going to be 28.1 here. There are some times in critical care when we might round it to the nearest 100 if we're using a pump. Your 4 is in the 100 space. So, NCLEX will sometimes call this 2 points past the decimal to the second spot after the decimal. Some people call it the 100th place. Whatever it is, this is definitely the second spot past the decimal, but the correct way is the 100th place. But now NCLEX, UWorld, and all them have gotten into calling this the second place after the decimal. I don't know why, but you'll see that referred to either way. Okay, now let's go back to our original question. So if you look here, we got 28.14, which I would just round to 28.1. And let's see if that's an answer choice for us on the question. All right, so if you look at number 2, it is. All right, everybody see B up there?
Yes.
Okay, so that's the part of the question. The other answer they were asking us for was the bolus. And the bolus is really no different here. It looks like a lot of information, but that bolus is just a one-time dose. So you already know what the dose is, right? It's 30 units per kilogram. So if you just take the 30 and multiply it times what we got for the weight there. So we got 78.18 infinity, right? So just take your 172 divided by 2.2 here. And then multiply that times 30 because that's what the order is for the loading dose. And you should have gotten 2345.45, which would round up. They probably rounded the weight is my guess how they got that answer. They probably used 78.2. Let me see. You guys don't have to do boluses. I'm just showing you that because I want you to understand it's just another simple calculation. There's nothing masterful there. Yeah, what they did was to get the bolus dose, they took the weight and they rounded the 70. What I say the weight was?
78.18.
Yeah, they rounded that to 78.2, and then they just multiplied that times the 30 units. That's how they got that bolus dose of 2346. 28.1 is what I would be testing you on, not the bolus dose. But I just want you to see that when you see that, don't freak out. It's just a little calculation. That's all it is. All right, let's look at number 2. Again, for number 2, it's asking us to set the pump in mLs per hour. Okay, so again, This is going to be a desired over half dose here, guys. Okay? And they give you all that information in the question. The only thing they don't give you is the weight. All right, so what we're going to take out of this is first, I always take the weight, which is 198. We'll take the order, which is 16 units per kilogram per hour. Take the heparin bag, which is what we have on hand, and that is 12,500 units per 250 ml, which is our vehicle. Everybody got those numbers?
Yes.
All right, so we have 198 divided by our 2.2. Sorry, my calculator disappeared into space. All right, so that gave me an equal 90. Okay. And now I have to multiply that times my 16 because our order is 16 units per kilogram per hour. That gave me 1440. And that's 1440 units per hour. Again, on hand, I have 12,500. And then my vehicle is 250, right? So units is going to cross out. And what'd you get? What'd you get, nurses? Don't be shy.
28.8.
Okay. Everybody got that?
Yeah.
28.8. Maria, I got that too.
Okay, good. Number two, 28.8 is up there, right? You see, these questions, you won't have to do any of these, but these actually give you the PTT, and they want you to calculate what you're going to give according to that because we use charts and stuff like that in critical care when we're doing all that. Okay, let's look at number 6. Number 6 is the same type of question we just did. I want you guys to calculate it. It's asking you for mLs per hour here.
Is it the 14.1, Miss Sue? Or you want me to wait?
No, you're fine. It is the 14.1. Did everybody get that?
Yes.
Yes.
Okay. So also in your book says that when your heparin dose is less than 50, you would increase it, and when it's greater than 100, you would decrease it for your APTT. Okay, and that's because we said that the APTT is typically 21 to 35. All right, and you'll see books, even your book with Brunner, on one page it does talk about, increasing it 2 to 2.5 times. On another page, it says 1.5 to 2.5 times. So that's the only discrepancy I see there in your book. And that is the differences are between page 673 and page 735. So you might, just want to ask your instructor about that when you guys start working on this chapter, okay? All right. I don't know if you guys are doing heparin, because that's really med surg, so you guys probably aren't talking about it in Geri that much, right? Hello?
Miss
Well,
Sue, are you writing the test?
I will be writing the test, correct.
Okay, can we just do like problems from what you're going to write on the test?
So that's what I'm showing you now. But
Perfect.
I'm still going to talk to you about things that you need to know, because that's how I do when I do
Okay.
the teaching, okay? I'm not showing you any problems you don't need to know.
Understood.
I'm
Thank
just
you.
talking to you about the concepts you need to know when you're administering this, because you're not just giving heparin, you need to know the concepts.
Correct.
All right.
Thank you.
It's the only way I teach. I can't half do it.
Miss Sue,
Yes.
I think my problem just now, I did the problem, but then it was rounded up. I'm a bit confused. I don't know where I'm confused at, but I'm confused. So with the problems prior to that, we didn't round. Now with the third one, we did round.
We actually rounded when we got to the answer. So
Right.
this one, you ended up with, so if you look at the problems we did previously, like the one we just did.
Yeah.
For this, let's go back to that for a second.
Mm-hmm.
The answer ended up exactly 28.8. So there was nothing to round because it was already in the nearest 10th.
Okay. Yeah.
Okay. The one we did before that, I believe we did round. So if you have two numbers here, if you have two numbers here, likely you're going to round it to the nearest 10th. If that said 28.889, you would likely round it to the nearest 10th. Usually your question will tell you where the author wants you to round it to. You guys' problem is you don't read. Okay? Because every problem on those tests tell you round it to the nearest 100 or round it to the nearest 10th. And most of the time, it's not your answer that's wrong. You didn't round it. So that's where you need to go back and say, like, did I really read the question? Did I answer what the question's asking me? Can you round a pump to the nearest 10th?
Are you
That's
asking?
what you also have to think about.
Okay, so bottom line, we just go to the nearest 10. So if like
That's not what I said.
okay, I'm trying to understand.
What did I say? I said you have to read what the question, like these don't tell you to round it to the nearest 10th. Why do you think that is?
I'm not sure. I'm trying to understand.
Because you don't need to. You can give it to the nearest 10th with the pump, and it's heparin. You're titrating a dose. If you just take it to the nearest round number, you're adding medication to that dose now. So it doesn't matter if you give them a little more heparin, right?
It does matter.
It does matter.
So that's what I want you to understand. And that's why it's so crucial. Like the reason why we do it on the test, I'm going to tell you why. Because you guys don't know your devices. I'm not saying everybody, but I ask a lot of people, if you were given this, could you round the pump to the nearest 100? And they'll tell me no. I'll ask them, how about an IM injection? Can you give that to the nearest 10? Can you, nurse?
No.
You
No.
can't give an IM injection to the nearest 10.
No.
Yes, you can.
Okay.
And this is where you have to know how you're giving it. What does gravity drip mean? Why do you have to calculate a drip rate? What would you use that with? When would you use a drip rate? Why do we even care if there's a drip rate?
So it could be properly monitored or given effectively.
Because you ever seen something called a roller dial?
Yeah, I've seen that before.
That's what a drip rate is for. Back in the day, we didn't have pumps all the time. We didn't have electric all the time. When we had Hurricane Sandy, no electric. So guess what you had to count? Because your drips set your ml per hour ultimately when you don't have a pump. If I'm giving somebody a dose in a medication cup, that's 30 mLs. Can I put it to the nearest 10?
I guess so.
Don't guess. Because
So
you're
this
guessing
is the
with
thing.
somebody's life.
Listen, I don't do.
But I want you to think about, do you give meds?
No, that's what I was about to tell you. I do home care. I do mainly wounds. So this is why I'm asking you, because I don't necessarily understand a lot of this. So, I mean, I understand it to a certain degree now, but that's why I'm asking you these questions, because this is not something I'm familiar with.
All right. Well, this is something that they actually should have taught you previously when you went to school, because if you're
Yeah.
administering medications, you have to know what device you're using, how you can measure it in that device, and how you would administer it. So, why don't we round up to a whole number all the time is because when you're giving things like dopamine, dobutamine, epinephrine, these kind of things are going to make drastic changes in your body. So you can't just round it up to the next whole number. How about when you're dosing a pediatric dose? Why do we have those safe dose ranges? Because we don't want to kill somebody's kidneys, liver, or them because we've administered the medication wrong. So, the reason why we put on there round to the nearest whole number or round it to the nearest 10th or round it to the nearest 100 is we realize that there is definitely a gap there between what you understand in the tool that you're administering the medication with and what you could actually do with that tool. Because on any one of these problems, you could definitely round it to the nearest 100 or the nearest 10th when you're doing the mLs per hour, because yes, you can set a pump, but with heparin, typically we're going to the nearest 10th. If this were dobutamine or dopamine, then we might be going to the nearest 100 because those are potent vasoconstrictors. And so you have to be careful how you administer them. All right. So this is part of the reason why I'm doing the education with the math, because I really want you to understand that when you're out there on the floor, it's not you just grab something and go. All right.
Got it.
All right. So how about the math part? Other than like not rounding it up, did you get the math part right? So you got to the 14.07, right?
Yes, and then I divided the 1407, then I divided the 2500. Then the answer I got from that multiplied it with where's the problem? The other number.
But your ending number should have been 14.07
And 27273.
sorry,
Okay.
for number 6.
Number 6.
Did you get for your final answer there?
And I'm fine if you want to try it. And you know, sometimes she takes big bites. But
Please put your computer on mute. For this answer, Mama, what did you get? What was your final answer?
Oh, the one that we just did was hold on. What was my final
The
answer?
heparin one, that with the 24 units, the 129 and the weight.
Well, I'm gonna tell you. I'm gonna tell you in a second. Oops. I think it was 28 point something. I did it and then answered the question. I have to redo it.
Okay, I want to make sure you know how to do number 6. So why don't you just work number 6 out for me real quick and tell me what you got for it and answer.
Hold on, was it number 6 or number 3? It was
Number 6 is the one that we were talking about.
Okay, can you pull that back up, please?
It's on the screen. What do you see?
I'm looking at the
whiteboard?
Yeah.
Okay, there you go, number 6.
Oh, okay. Yeah, it was 14.1.
Okay. All right, anybody else have an issue with those problems? Do you need to do more like that?
Not sure. Not sure. This is Maria. I don't.
How about everybody else? Guys, if you don't talk to me, I don't know what you need. Then it's wasting time for us to be on here. I need you to communicate with me.
You could go. This is Andrea, Miss Lowe's, but I do understand these ones. For me, honestly, my issue that I'm having is time, because I know it's a time test, and for me, like even last night, I was working over the package that they sent in the email, and I sat there, of course, because I wasn't timed, and it gave me enough time for me to see what I was doing wrong, reword it, and re-figure it out, flip my numbers, however. So when I'm taking the test, it's for me, it's a time issue for myself. And my anxiety go at 100 miles an hour, knowing that I'm timed and not having enough time to even sit and process what the question is asking. So for me, it's not getting the problem for most of them, especially these when I understand these ones. It's just my anxiety is just the time management for me.
Okay, and what about everybody else?
I agree, Andre. I'm the same way. It's Louisa. I'm the same exact way. I can get the answer. I just need more time.
Okay, so I am going to give you more time. The majority of the test now will be either 10 or 15 questions.
It's a mixture. That one is
How much time do you guys think you need to do that amount of questions?
Well, for me, Miss Sue, this is Maria. I do my math problems the dimensional analysis way, so it takes me a little longer.
Okay.
But the time, I mean, it's an issue for me for any test. But
okay, but
for
let's
me,
just
it's just
talk about for the math. So for the
me,
math, for 15 questions that are these types of questions that we're doing, what do you think you guys need as a fair amount of time to do the test?
With 15 questions, 40, 45 minutes, I don't know.
Okay.
Because some of them you could easily go through them. It's the ones that like, because even for these heparin ones, what the issue that I was having with these heparin ones, I thought the confusion for me, I was flipping the bottom numbers. So it took me going through like a couple of your slides to understand that I'm keeping the bottom number and working with what the weight plus the unit was asking. So it took me a minute to get there, but once I got there, it was just like, okay, so I could work through these. The ones that is the one that is worded tricky for me is what I hang up on, or it's I don't know, like the formatting is just different from what I'm used to. The tricky questions. And for me, understanding what is the fluff. Like even last night I was doing what it was 250 over 250 per 1,000 ml. And it took me a minute to understand like one of the 250 didn't matter. So for me, it was just like recognizing what the fluff is. So that's where I'm having an issue in. So that's my problem. So now this is the platform where we voice what issue we're having, that we could easily solve it together. So individually, that's my issue that I'm having, like recognizing what's the fluff and time.
Miss Sue, is it possible that we can get it a multiple choice or no?
No, we do not do multiple choice. You need to be able to calculate the math, but I'm trying to work with you on the time. So does everybody agree for a 15-minute test that 45 minutes is a fair amount of time?
Yes, I agree.
Yes.
Yes.
Okay.
Yes.
All right. So then that's what it'll be. All right. So now I'm going to go back up to the top question, and I want you to go through the question again. And I want to see if everybody can get to the 28.1. So do the math and see if you can get an answer of 28.1 here.
Yeah, I was
Everybody
able
can
to
see the
first
math
time I
problem?
did it.
For
I'm
number
sorry?
2?
Number 1, everybody can see it?
Yeah.
Yeah.
Yes.
Oh, I didn't do number 1. Let me work it out and see.
Yeah, I was able to do it the first time you did it.
But I still want you to go back through and make sure if you're not having any problems with the flow, then fine. But can you do the steps and get back to the 28.1? That's what I want to make sure.
Yes.
Yes.
Everybody on here can do the steps and get to that number.
Yes.
Okay. Just gonna pause this for a minute. We start here with what the question's asking us. Again, it's asking us for mLs per hour. So this is going to be desired over half. Okay.
Okay.
All right. So out of this question, you're going to take your weight, which is 198. Your order, 4 micrograms per kilogram per minute. And what you have on hand, which is 250 milligrams per 250 ml. Everybody got their information?
I got it.
Okay, if you don't say that, then I assume you have it. All right, so our weight is 198. Again, I leave everything in the calculator. Oh, let me go let my puppy out real quick. All right, 198, do the calculation. It's divided by 2.2.
90.
Sorry about that. Okay, 198 divided by 2.2 we got, right? What do we get?
90.
Okay, then we're gonna multiply that. So that is 90 micrograms per minute, okay? That's what we got, because we took our, I'm sorry. See, that's what happens when you walk away from the screen, Miss Sue, then you make mistakes. Let's go back here for a second. We have 90 kilograms. You guys correct me if I'm doing it wrong. That's part of the learning process, okay? I could be wrong too. All right, so 198 divided by 2.2 equals 90 kilograms. And then we're going to multiply that times our ordered dose, which was 4 micrograms. And that gives us 360 micrograms per minute. Okay, everybody with me now?
Yes.
All right, we have to get to mLs per hour, okay? So we're going to have to do some conversions here. All right, so the first thing that we're going to do is we're going to take our 360 and we're going to divide it by 1,000 because we need to convert this to milligrams, because what we have on hand is 250 milligrams per 250 mLs. So everybody understands why we have to convert here.
No.
Okay, so you had a ordered dose for 4 micrograms per kilogram per minute, right? And you took your weight, you divided it, you multiplied it. Now your dose ended up with 360 micrograms per minute. But what you have on hand is milligrams.
Okay.
So you have to convert your 360 micrograms to milligrams. So in order to do that, you're either going to move the decimal or you're going to divide it by 1,000, right?
Okay. That's where I was messed up at.
Okay, so take your 360 and divide it by 1,000. And that should be 0.36. So now you have 0.36 milligrams per minute. You still have to get to hours because you're in a minute and we need to know for hours, okay?
Mm-hmm.
So the next conversion you're going to do is you're going to multiply this minute times 60, and that's going to convert that time to 1 hour, right? Since you multiplied that side times 60, you're also going to multiply the 0.36 times 60. And that should give you
21.6
milligrams per hour. Okay? Now you're putting that on top of what you have on hand, which is 250 per 250. Your milligrams are going to cross out. And now you just do the math, which you should still be left with 21.6, right? Because 250 is going to cancel itself out. I just asked if you guys have
So 21.6.
that you please mute, because I am recording this for some other students and they won't be able to hear it if there's background noise.
Miss Sue, I got lost at multiplying to get rid of the minutes to turn them to hours.
Okay. So let's go back up and just start. So we took the weight, we divided that, and then we took our weight and we multiplied it by our ordered dose. Our ordered dose was 4 micrograms per kilogram per minute. Okay. So when we took the 90, which was our weight, times the 4, that gave us 360 micrograms per minute. Our problem answer has to be in mLs per hour. So in order for you to get it to mLs per hour, you're going to have to convert that minute into an hourly rate. And so in order to convert your minutes into an hour, you multiply them by 60, right?
Yes, so I'm multiplying the 60 times with 360?
You could do it that way, but you still have to convert. Remember that before that, what did we do before that step? We also had to convert our micrograms into milligrams, right?
Yes,
So we actually converted that 360 to 0.36.
right, okay, I'm there, okay.
So I put the 0.36 times 60.
Okay,
And that should have gave you 21.6 milligrams per hour.
there, okay, I have that.
We're going to do another one. Everybody's with me here. Anybody else besides Miss Brockington not quite catching this?
I got it.
All right, so let's go back to our screen. We're going to do another one. Don't worry. All right, 21.6 is up there, right?
Yes.
All right, let's look at number 3. Number 3 is the same type of question, okay? So we're going to do the same exact steps. So again, it's asking us for mLs per hour. Look at our problem. We have an order for micrograms per minute. And on hand, we have milligrams per ml. So right away, that should tell you what? What do you have to
You
do
have to
solve this
convert.
problem?
You have to convert.
You have to convert. Okay, so you're going to have to convert your minutes to an hourly format. And you're going to have to convert your micrograms to milligrams or your milligrams to micrograms. I don't really care how you do it. I have a certain way I go through the problem every single time. That way I don't get lost or confused. So that's the steps I'm showing you. You could use any steps you want. The bottom line is, were you able to get to the answer? So you got to have some formula or some step process, because otherwise, if you don't do it the same way every time, then you are going to have issues. All right. So let's start with the weight. And that's why I go through this whole process. I look at what the question's asking me, mLs per hour. So I know right away by looking at the information in this question that this is going to be a desired over half. And I have to first calculate my desired dose because I don't have it. I know what the doctor wants, but until I do the weight conversion and that math, I don't have my desired dose yet. So the first part of this problem, we're calculating our desired dose. Okay? So our weight is 298. Write that down. We need our desired ordered dose, which is 30 micrograms per kilogram per minute. And then what we have on hand, which is 4 milligrams per ml. Again, I always start with the weight, which was 298. And I'm going to divide that by my 2.2, leaving everything in the calculator. So that gave us 135.45. I put this line here because that represents infinity. On paper, that's how I write it. In the computer, in the calculator, I leave all the numbers there. All right, so now we have our desired dose is going to be our 135.45 times the ordered dose, which was 30 micrograms, right? And I got 4,063.63 blah blah blah, and this is going to be micrograms per minute. So if you got this problem and the author simply asked you to calculate the micrograms per minute, you would stop right there. But you're doing mLs per hour, right? All right. So next step is what?
Conversion.
Yes. It doesn't matter which one you convert first, by the way. I don't care. You're still going to get the same answer if you do the math right. What works for you, nurse?
I'm gonna convert right here.
So I'm dividing this by 1,000. All right. Or 1, 2, 3, and I should get 4.063. And then I don't really need to multiply this by 60, but I do it in my head anyway. Okay, because it just reminds me that the reason why I'm converting this is because my answer has to be in hours. And now we have 243.81 milligrams per hour. What we have is 4 milligrams per ml. Again, depending on your author, whether they'll leave that at 60.9, round it to 61, because that would be your next round. You can't round that 9 up without rounding the whole number, right?
Right.
Did you guys get to that answer?
Yeah.
Yes.
I got to that answer, then I rounded because the answer was 61.
I got to the answer as long as you talked me through it.
Okay. So on here, you would have picked 61 because you would have got the answer that's closest to that, and that's what you would have picked, right? On the test, it's going to tell you whether it wants you to round to the nearest 10th. All right, so the next one you're going to do on your own, nurse, without me. Number 5. Think about the steps. Number 5 might have been a bad choice here, but just look at your conversions, okay? I didn't realize that this isn't exactly like the one that we just did until just now. So, but you can do this. There's one step you're going to leave out of here, and I want you to think about why. And this is where your critical thinking comes in.
Yeah, this is Maria. I got C on my end.
Okay. So the one thing you didn't have to do here is convert your time, right? Or your strength, because those were already set for you.
Correct.
So that's where you have to see where that critical thinking comes in, okay? That 500 milligrams is not fluff, and we don't use the word fluff. That's part of the order, but do you need it for the equation?
Yeah, I got C as well.
Okay, so was everybody able to get to C? It's actually kind of good that this was a little different, because hopefully you were able to use those critical thinking skills and say, hey, wait a minute. I don't have to do as much work here, right?
Right. So problems like these, Miss Loesch, is what I was referencing to when like recognizing what matters and what doesn't.
Okay, so your problem is the same thing. This is desired over have. It's asking you how many mLs you will administer. So you're going to do the same steps. Take your weight, which is 98. Take your desired dose, which is 5 milligrams per kilogram per hour, and take what you have on hand. 500 milligrams per 100 mLs. That's what matters there. So we have a weight of 98. We're going to divide that by 2.2. That would have gave us 44.54 infinity. Our desired dose is 5 milligrams per hour. And since we have our ordered dose is in milligrams, we don't have to convert there, right? What we have on hand is already in milligrams. So now we can just take our weight, multiply times that. That should give you 222.72 infinity. And this is already in milligrams, right? So it's already milligrams and it's already hour. So now you're just going to cross out your milligrams and you're going to be left with mLs per hour once you do the math. And that would have left you with 44.54 or 44.5. You good?
Yes.
Yes, I got it.
Yeah, I got it.
Okay, now I'm going to go back to the other one on purpose because I want you to go back and forth. So let's do number 10. Again, you're starting with what your question's asking you. So it's asking you for mLs per hour. So right away, by looking at this problem, you know what?
I'm sorry, Miss Sue, I missed which problem we were.
Number 10. It's asking us this, so how are we going to set it up? What's the formula?
Can you move the arrow? The search is covering some part of the problem.
Oh no, more. Mommy.
It's probably on your screen, but I moved it. All right, everybody's got their info? All
Mr.
right,
You're not
everybody
talking, right?
able to get to that answer? I'm sorry?
No, I saw you doing all the writing. I thought I just couldn't hear you.
Yeah, I was just writing the problem out while you guys were doing it on your own.
Oh,
Just putting it on the screen so you can go back and look. Did you miss any steps? Did you get the right answer?
Finally got the right answer.
Everybody was able to get to here.
Yes, it took me a minute, but I was able to
It
get
took,
there.
yeah, it took me a minute, but I forgot the conversion, the 1,000 part. I have to do
Okay.
that. So I had to
Same,
go
that's
back
what
and
I
redo
forgot
it.
too. Yep, and
Yeah.
yeah, same.
And our answer's there, right? Yes?
Yes.
yeah, yes.
All right, so is everybody good with that part now?
Yes.
Yes.
Okay, so we're going to switch over to a couple different heparin questions now. Now we're going to look at number 3.
So Miss Sue, can I ask you a question just for clarification? I understand what you did and I'm understanding the process. However, the question is it at all times? Even if it's asking you for ml, you still have to do that conversion to divide by 1,000.
The only time you have to do the conversions is when?
I mean, if it's asking you for if it's in micrograms, I would think you would convert it, yes.
Only
However,
time
I
you
guess
have to convert is when your desired dose is in a different strength than what you have on hand, or if your time is in minutes but you need hours, or if your time is in hours but you need minutes. So those are what times when you have to convert. You have to be able to see that in the problem.
okay.
So if your desired dose is in micrograms and you have milligrams on hand, convert. If your
Could you
time
scroll up?
is in minutes and it's asking you for hours, you need to convert. If your
Could
time
you
is in
scroll back
hours
to number
and it's
10, Miss
asking you
Loesch?
for minutes, you have to convert.
Okay. Could you put number 10 back on the screen just for me to look at it again visually? Please. Because I know we did the similar problem earlier, but I was just going back as to how I end up
I
missing
want you to
the
look at
1,000.
I want you to look at the difference. This is asking you
Mhm.
for mLs per hour. Your
Right.
order is in micrograms per minute. What you have on
Mhm.
here is milligrams per ml.
Okay.
Look at the other problem we did, number 5. What's the difference?
So it's already in the milligrams.
Right, and the time is already in an hour.
And it's already hourred out.
Again, it comes back to carefully reading that question and
Right.
using those critical thinking skills. Because this
Mhm.
isn't just math, it's also teaching you how to critically think.
Right. Well, I just don't want you to move on from this platform where we need clarification without having the full understanding. So while I missed dividing the 1,000, yeah, I just wanted to see
Listen,
why.
ask as many questions as you want. I don't get mad. I'm just
Okay.
loud. I'm loud and boisterous, okay? And I didn't have my tea today yet.
Uh-oh.
It's not 5 o'clock, silly. All right. So we're good here?
Yep.
Yes.
I think so, just with some practice, yes.
Okay, now we're going to go to a little bit different style question. Okay, so look at number 3. All right, so on this question, it's asking how many units per hour is the patient receiving? All right, and you know that your pump is running at 36 mLs per hour. And on hand, we have 12,500 units in 250 mLs of solution. Okay? So the first thing for this one you have to do is take your 12,000. Oh, I put too many zeros there. Should be just 12,500. Okay, so we're going to take this 12,500 and we're going to divide it by our 250 mLs. And that is going to tell us how many units we have per each ml. And you should have got 50. So we have 50 units for every ml. So now, if you have 50 units per every ml and you're running 36 mLs, then you're going to take your 36 times 50. What'd you get?
I got 1,800 for the answer.
1,800 units. That's what you should have got. Right there, number 3, 1,800. See, if I go down here, the answers are probably at the bottom. Okay, there's number 3 right there. 1,800 units. Let's look at the next one. Number 4, same question. See if you can do it. Again, we had 10,000 per 100 ml. And we're running at 29 an hour. Ten thousand divided by 100 equals 100. We take that times our 29, and that should give us 2,900 units. And it's up there, right? Let's double check it. Okay, 2,900 for number 4.
So, Ms. Loge, does it matter what number you multiply first? Would it be well, never mind. Well, would it be like 29 times 100 or 100 times 29? It would be the same outcome, I guess. I didn't do it that way. I'm just asking this for mindset.
Shouldn't matter the multiplication, which way you do it. But if you're using your calculator, you should have been left with 100 in the calculator. So all you had to do was multiply it times the
Time,
29.
okay. Okay.
All right, let's just go through and do the rest of these on this question. So we're going to start with number one. I want you to do number one, even though we just did it. I want you to throw the paper away that you did it on, put it to the side, get a fresh piece of paper, and we're going to go through each one of these, starting with number one. Again, you're taking the weight, the ordered dose, what you have on hand. The weight is 198. I end up with 90 kilograms. I need to multiply that times my ordered dose of 4 micrograms. It gives me 360 micrograms per minute. Going to convert that to milligrams by dividing by 1,000. And then I'm multiplying it by 60 to convert my time here to an hour. Now I have 21.6 milligrams per hour. Of 250 milligrams per ml. I'm sorry, times 250 ml. Milligrams cross out. 250 is going to cross out. It's going to leave me with 21.6 milliliters per hour. We go to the next one. So this is telling us how many milliliters per dose will you administer. So this is a desired over half. So it's a weight-based dose. So we're going to take our patient's weight, which is 93 kilograms. Our ordered supply is 50 units per kilogram per dose. And we have 5,000 units per ml on hand. So our weight is 93 kilograms. Our ordered dose is 50 units per kilogram. That's our ordered dose. This is what we have on hand. And that's what we're going to give per dose. Everybody with me still?
Hi, mommy.
Yes, I am.
Yes.
Okay, our next one is another weight-based one. So we it's asking us for mLs per hour. You already know this is desired over have, right? So first thing we got to do is calculate our desired dose. So we're going to take our patient's weight, 298, our ordered dose, which is 30 micrograms per minute per kilogram, and then what we have on hand is 4 milligrams per ml. Start with our weight, leaving everything in the calculator. So our weight is 135.45 kilograms. This is infinity, okay? Leave it all in the calculator. Now we're going to take that weight and multiply it by our ordered dose, which is 30 micrograms per minute. That gives us 4,063.63 infinity. Again, we're leaving everything in the calculator. Micrograms per minute. On hand, we have 200. I'm sorry, on hand, we have 4 milligrams per ml. So we have to convert this micrograms into milligrams by dividing it by 1,000. And that gives us 4.063. Remember that 63 is infinity, and this is milligrams per minute. Now we have to convert our time to an hourly rate because our problem is asking us for mLs per hour. So we would normally multiply this side by 60 to make this 1 hour, which means we also have to multiply this by 60. And that gives us 243.81 milligrams per hour. Milligrams cross out, and we'll be left with mLs per hour. We divide this by our 4, and that gives us 60.95, which would likely round up to 61 mLs per hour. Everybody with me?
Yes.
Okay, we do have 61, so we're going to select it. All right, next one is how many mLs per hour will you administer? So for this, we need our desired dose, which is, our weight, 87 kilograms, so we don't have to convert because it's already in kilograms. Our ordered dose is 20 units per kilogram, and it's per hour. And since we're going to mLs per hour, we won't have to convert there either. And what we have on hand is 100 units per ml. The patient's weight is 87 kilograms. We're going to multiply that times our ordered dose, which is 20 units per kilogram. Is a 1,740 units. On hand, we have 5,000. I got 0.3, so I just want to make sure I put everything in right. Probably right, but all right, let's see. Did I read something wrong? I read something wrong. What I read? Oh,
No, it's 100 units.
okay. I had 5,000 and it's 100, right?
Yeah.
That was the issue. So, okay, so let me do the math again, right? So we had 1740 divided by 100. So you should have got 17.4. And that's why you just always go back and double check, because sometimes I do write the wrong numbers down, and so do you. This should have been 100. If I had the right numbers in there, the answer would have been right, but I had the wrong numbers in there. All right, so 17.4. Again, don't ever be afraid to call me out if I'm wrong, if I make a mistake, because that's good for you. That lets you realize, hey, I'm doing the math right. Miss Sue screwed up. So what? I screw up all the time. I try to be right, but you know, I'm human. All right. Let's look at the next one. Again, this is just asking us for mLs per hour, so we just need our desired dose over what we have on hand. Our patient weighs 98. We have 5 milligrams per kilogram ordered, and it's per hour, so we're good there. And then on hand, we have 500 milligrams per 100 ml. We have our weight. We have 44.54 infinity. Okay, that's our weight, kilograms. We're going to multiply that times our 5 milligrams. And on hand, we have 500 per 100. Kilograms crosses out here. And you still end up with 44.54. We'll drop this, okay? How we feeling? Want to keep going through the rest of them?
I feel a little better.
I do too.
We have a couple more minutes if you want to go through the rest of them, or you want me to show you anything else that you're not sure about.
I'm good for now.
All right, once we stop, I'm gonna this will convert, and then I'm gonna send you guys the recording.
Thank you.
Thank you.
So just
Thank
go
you.
back, review the recording, go back through the steps, make sure you can do it.
Thank you.
And if you're still individually feeling lost, you can reach out to me individually. Like if you feel like you're just not getting it with the group, then let me know.
Thank
All
you.
right.
Thank you, Miss Sue.
All right, guys, have a good Saturday.
Yes, thank you. Appreciate it.
Thank you, you as well.
Thank you.